Good morning, good afternoon, or good evening, whatever time you're watching this educational video. Now let's continue what we had discussed a while ago about how we derive the square root of GR, 5GR, or 4GR, or 2GR. Okay, and this time, this is the problem that I introduced to my physics class, and then we bubbled by the situation of getting or we were not able to get the bottom speed for this equation. So in our problem, we have a 32 mechanical object is attached to 2-meter radius rope pulling the objects with 28.5 newtons. 28.5 newton is our tension force here pulling the object, and there's a rope here as our north star. And then it rounds vertically at a certain top speed as it attempts to complete the rotation. Now let's determine the top speed as well as the bottom speed of this problem. Will it make it to make a complete rotation? Okay, let's try to find out. All right, this is the problem. And then we have our mass, of course, mass of the object. We have radius, that's 2 meters. And then we have the FT or the tension force. And our target is to find what is the approximate top speed as well as the bottom speed, right? Um, yeah, let's determine the top speed and bottom speed and if it will gonna make it to have a complete loop. Okay, so our top velocity, we need to find it first by using our formula of tension force. Okay, tension force is equal to centripetal force minus the weight, and that's it. And we will substitute now our given. So FT, we have 28.5 from the problem. We have 3.2, that's the mass, and then the radius is 2. Mg for the weight, that's mass times the gravity, 9.8, constant. Okay, so we will continue. Now, 3, 3.2 times 9.8, it will give you negative 31.36, and then 3.2 divided 3.2 divided by 2, you will have 1.6. Okay, and let's retain that tension force here. Next, we will substitute 31.36 to the other side, and it will become positive. Okay, positive 31.36.28 plus 28.5 equals 1.6 v squared. Our target is to isolate velocity to get the top velocity. Okay, now we will add 31.36 and 28.5. It will have 17 59.86. And then 1.6, we will divide both sides by 1.6 to isolate v squared. And we have v squared is equal to 37.41. 59.86 divided by 1.6, it will give you a quotient of 37.41. And if you note, it's still in squared, so we need to do this next step here. And the square root of 37.41, it's 6.12 meter per second. That's the top velocity, approximate top velocity. And in order for us to know what is really the minimum velocity in this problem, we have 2 meters as the radius and 3.2 as the mass, but we don't need that. We need the radius and the gravity. Okay, so minimum top velocity, that's v is equal or greater than gr. Okay, so in this case, 9.8 multiplied by 2. 9.8 is our gravity and 2 is the radius. It will give us 19.6, and then square root of that, it's 4.43. Obviously, if we will compare it, 6.2 is greater than 4.43, the minimum top speed, therefore it can sustain. The speed can sustain with this tension of 28.5. Okay, it can really sustain because it's greater than our minimum top velocity. Okay, with 28.5 tension force, it can sustain the motion at the top. Now, what about the bottom velocity? This is now the problem we had, that we never really, we never really solved, or we never really end uh, the confusion when we were dealing with this problem. So the bottom velocity, instead of minus weight, you will have plus weight. Okay, just like that. Then we will substitute now the given ft is 28.5. 3.2 is our mass, 2 is the radius, but this time we will add the weight. It will give you this values here. We divide 3.2 by 2, it will have 1.6, and then multiplying 3.2 by 9.8, it will give you 31.36, but this time it's positive. Now we will transpose or transfer this term 31.36 to the other side. It will become negative, negative. And then we will continue solving. So 31.36 negative 31.36 plus 28.5, you will have a difference of 2.86, and we will follow the negative because it has the greater absolute value. And then we will divide both sides by 1.6 to isolate velocity. So it will become 1, and 2.86 negative divided by 1.6, it will have a negative quotient of 1.79, and we need to get the square root of both equations, and it's undefined. In physics class, if ever it will gonna happen, this is something that I never explained to you, okay, to my physics class. If ever it's undefined, it means that the tension is lesser or weaker. So in that case, it cannot really sustain the motion because the tension is lesser than the weight. Okay, so no complete loop, and it's okay to have a negative inside our square root. If it's undefined, we can definitely interpret it that the tension force is lesser than the weight. So in that case, it cannot really be able to sustain the motion. Okay, so this is something that I never gave during our discussion, but this time it's fine. Okay, so it cannot really sustain. So the bottom velocity cannot really complete the loop because it has a weaker tension force. It will gonna be break or slack or oscillate in whatever direction.